that schedules, you can schedule jobs for tasks that you want to execute. And this is covering some of my text. That's probably that. So you can basically send a job to the queue, it will run in the background. And some of the advantages of this is that it can be done in parallel, and things can be done out of band, and it's really useful for like a website where if you have a long-running task, you don't have to sit there and wait for it to finish, like, and delay the user. So here's kind of like a very technical explanation. But basically, Celery communicates with RabbitMQ. This is obviously a little inaccurate, but Celery communicates with RabbitMQ, and RabbitMQ kind of distributes the tasks to run. Chris mentioned that I should have brought some Celery along. I would like to share some hands-on log with everyone, but not today. So some real-world examples. There's like multimedia encoding. If you have to upload a very large file, you can have a job run in the background and do some massive data encoding or something like that. Bulk messaging, if you need to send out like an SMS message, or like a few thousand SMS messages, let's say, you can create a job that will go in the background and just start sending messages, so you're not delaying your user response. We've used it for contest scheduling. For example, you can schedule a contest to happen in the future, and then when that time comes around, we'll execute the contest, and further jobs can be spawned off of that job to mark certain milestones in the contest lifecycle. A few terms. First of all, RabbitMQ. This is a server written in Erlang that just kind of sits on, could sit anywhere, but in our circumstance here, we're just going to have it run locally. And it's basically, as I kind of mentioned before, schedules or takes in tasks, figures out when they should run, and doles them out to worker processes to get them run. Celery is a kind of an API for that whole process, and it's got some daemons that run, which I'll explain in a bit. That you can use Celery for not just Django, you can use it for other frameworks as well, but I'll be talking about Django in this case. Celery D is it's part of Celery, and it's a worker process that runs in the background that the RabbitMQ server will send a task to the Celery daemon to have it actually executed. And I'll get into more detail about that. Django-celery is the kind of add some hooks for Django to add some management commands, some client code, like some monitoring and some storing results, and you can view the tasks in the admin interface and a variety of things like that. So it adds a nice layer that integrates Django with Celery. Celery also works. By the way, the RabbitMQ is also called a broker. It's a message broker. It sends out, or basically takes in the messages. Or, there's different types of brokers that you can use in place of RabbitMQ. We're going to talk about RabbitMQ right now, but you can see the list is long. This is taken from the Celery website. So here's kind of one. This is right off the website. Again, this is a RabbitMQ here, and it doles out to various worker processes. You can have one, which in our case, we're going to just have one worker process, but you can have as many as you need. So you can have these, have tasks run massive parallel. And then there's a results store that can be used to store the results of the messaging of the task success. This is kind of a document that I put together to help me kind of visualize it a little bit better. Just another look at it. This is your Python web application. with Django-celery, and then you have the Celery Client, which is basically the invocation code that creates a task, and it will send it off to a RabbitMQ, which will, like I said, schedule it. When it's timed, when it's supposed to run, then it will send it off to the Celery daemon worker processes, which is also another Django instance. It's a full instance of Django, and these are often the same virtual environment. Or if you want to run this on a separate server, you might have them sharing the same code or the same checkout of the Django code. But essentially, you're running all of these worker processes are running the Django context as well as your Django application. And then the result store in this case is a Postgres database, and it will write records to the Postgres database when it needs to, and the Django application can access the result store through querying it and various things like that. Let's see. So for our example, we're going to use an Ubuntu 11.10 actually. RabbitMQ, Python 2.6, Postgres for the system. Django-celery requires, as far as an apt package, it just basically requires the RabbitMQ server, and I like to throw in virtual environment, virtual ENV. And also, something that's not on here is you need like a C compiler, like Jasinski to compile the Celery pack or the Celery Python package. And then the Python requirements is Django, Django-celery, and Celery. So it's pretty easy to set up there. So when you install the RabbitMQ server, you need to basically create an account, like a username and a virtual host. And I just documented the commands, the pretty standard commands, to create a user and give it a password. And this RabbitMQ CTL command, that's like a command line interface for RabbitMQ. So there's a lot of different options you can use that with, but these are to get you started. And then you're creating a kind of a user, a virtual host, which is like a sphere of access. And then you're going to give that user permission to access that virtual host. The Django settings changes to settings.py is pretty straightforward. You're going to add this little autoloader snippet. You're going to set the broker connection information, which is what we set up in the previous step. And then add Django-celery to your installed app settings. And then to migrate it, you have to create the tables for storing the results. So that's done through migrate, or if you have South, it's South enabled. So, actually, yeah, I think I switched them. Oops. Then there's like, when you set up a Celery environment, you have to run these daemon processes in the Django context. And this is, of course, you have RabbitMQ just sitting out there on your system, which is completely independent. But these management commands, although a few of them are required to be running, several of them are useful. And so the most important one is the Celery daemon process. And when you start the Celery daemon, it will again take the Django context and start or be ready to accept tasks from the RabbitMQ. And then when it needs to run something, it's got the full Django context. It can access all the models. It can do whatever it needs to do that any regular web app will do. And also you have, like not included in there would be your run server command if you're doing it locally, or your web app or your web server. But you run that separately too. And these all run in separate terminals. Celery EV is a like a curses tool for monitoring tasks. It just kind of shows you a status of all your tasks out on the schedule, and as tasks come on, you'll see whether they've succeeded or failed or not. Celery Cam, this is a tool that saves like snapshots of all of your tasks, your current tasks, to the database at an interval that you can specify with an option. You can go and see those results later on. So here I'm explaining the command line options for Celery Beat. The -B is Celery Beat, and this is a task scheduler. So if you want to use Celery, you don't have to run messages right away. You don't have to run tasks right away. You can schedule them for some time in the future. And this Celery Beat is a daemon that runs to allow that kind of scheduling to happen. And there's also a separate management command called Celery Beat. You can run separately if you don't want to do this, if you don't want to pass them the option. But I find it convenient to use the -B option. One thing to note, though, is Celery, there should only be one instance of Celery Beat running. So if you have like 10 workers, only one of those should be a Celery Beat, or only one worker should be instantiated with the -B option, or only one version of the Celery Beat management command should be running. The -E option is handy because it sends out events, and events would be like whether or not a task is on schedule or whether or not a task has failed. It basically makes tools like Celery EV and such in the Django admin able to like hook in and see the results of the tasks. And then I just put in -L because this is handy for debugging the logging level.
Question?
Sure.
If you've got more than one task with the -B option, what kind of errors do you see?
Well, I mean, I have never done it, but apparently it starts multiple, like if you have a job scheduled in the future, it will start 2 jobs at that time. Here I'm going to show a task that you create, and this I'm kind of highlighting the worker processes because the tasks kind of run on the worker process. So in a Django app, you would want to create a tasks.py, and I think this is a standard. I'm not sure if it's required, but I think the documentation says to create it there. And for this task, we're just going to do a very simple thing. We're going to add, and now these are out of the docs, so it's not not too fancy yet. But we're importing a decorator from Celery, and we're just wrapping a little function with the decorator, and that basically defines it as a task. Here is another way to do it, passing a parameter to the decorator, which basically says, I don't care about storing the results for what this task does. It might be a task that modifies some database record or something, so you don't need to store that. Let's see. Okay, and then on the client, it's again in this segment of the flow, and these client calls could be in your views, they could be in your save overrides, they could be wherever you want them essentially. But these are where you invoke, where you actually want to schedule something. So the user uploads something, this could be in your view, and you can run this command, this apply async command, to start running your tasks. Basically, well, first of all, there are 2 syntaxes to support. There's this tasks here is the module that you just defined. So you import my app tasks, and tasks is the module you define, add is the function that you declared a task, and then apply async is when you decorated it, it turned into an object, but the apply async is what actually runs in the background, and you can pass arguments. If you recall, ours was an add function, so it's passing a 1 and 2, which should return a 3. Another syntax is to use this delay syntax here. It's just a different way of declaring it. I prefer to use the apply async, but this might be simpler, less typing to do. You can also pass in keyword arguments instead of just args. If you have functions, the function takes a keyword argument.
Wait. So in this case, does result end up with 3 immediately?
So, no. What will happen is this result is an object. It's not the actual result. So the object is a celery result object that you can query later, which I'll have some examples and I'll show a little bit. You can query later and actually you can get to see whether it was successful or not. You can see if there's an exception associated with it, and you can see, of course, the result.
Okay.
So here's these examples are in a Python shell. As you can see, the result, you can see if it's ready, if it's been completed, if it's successful, you can see the state, or there's a function or method that you can access. There's also a fail or a failure method. And there's each task is assigned a unique UUID task ID, which you can kind of use to track within your within the Celery EV or the Django admin. And here's where you get the result, and you can get the task name, which by default is the name of the task as defined in the task.py. So you can also override the name and give it something else by decorating your task parameter. Here's an example of running a task at a specific time. So if you want to run a task, on March 4th, 2012 at midnight, you can pass the ETA argument to the apply async function or method, and it will sit on the schedule until that time and execute. Now, if like your Celery daemon is not running at that time, it will spawn up as soon as the Celery daemon runs. It will catch the or it'll grab the task and start running it whenever it becomes available. And similarly, if you set a time in the past, it will start running immediately. Another option is the countdown argument, which gives you the time in seconds that you want it to run in the future. So if you just want to say, run in a minute, then it will run in a minute. And,
where does Celery store that if you want to change your mind and don't want to run it?
there are ways to access it functionally and via the monitor and via RabbitMQ. You can actually go in and cancel a task. But I haven't done too much exploration into that. It should be something which is better. But you can, Celery EV is really easy to cancel a task. You have a little graphical tool, which I'll show you. You can kind of toggle up and cancel a task. Here's kind of an interesting method for the result object, and that's wait. And that will just freeze your terminal or freeze the flow until the job finishes. So you probably don't want to use that unless you have some reason why you want it to wait, but that kind of defeats the point. Here's an example. I figured here's an example of how to start doing this with the Django model. Now I'm just going to create a contest model which has a status, which takes a not started, running, and complete, a name, a start date, and end date. And then here's some sample tasks that I might define in this would be my task.py within my module. And basically what it's doing here is it's importing the models, my models, and then it's getting the contest module, like it's passing in a contest ID, and it's looking up the contest object based on that ID. And this is, I know, a little unconventional. You're saying, why don't I just pass the contest in there, contest ID there? And I feel, I know there's some concurrency issues, and I feel looking it up each time, make sure Django doesn't cache it. There might be other ways, better ways to do this, but I prefer to pass in a solid ID that won't change, and then I can look it up in my task. And then I'm going to set the status to 1, defaults to 0, because that's what our last our model definition said. I'm going to save it, and then I just sleep just to make it look cool, like it's doing something. And then here I was going to do something fancy and kick off another task to start in at the end date of the contest. So whatever I set my end date would be in the contest, it would schedule that task at that end date. And here's my end task, basically doing the same thing, except it's setting the status to the stop status. You can kind of chain these things, so when this one runs, it will schedule the next one, and when this one runs, it will schedule the next one. That's one approach. Let's see. So to run this, I am creating some, like a fake, or just a test contest, and I'm setting a start date and end date to be 3 minutes and 4 minutes in the future, and saving it. And I was just, well, I think there should be a 0 here, but it's not. Then here I'm running the task, and I'm passing in the contest ID, which was the parameter for the contest task. And here I was just waiting. I don't know why I did that, but oh yeah. And then I looked up the model again because I was, needed to refresh the cache, the Django cache. From your perspective, like the task is run, it's updated the model, but if you're in an interactive terminal like this, it was caching the results, like the status wasn't updating to 2. I was relooking at the model here, or the model instance. Here's an example of, I wanted to, actually, I'll take this time to do kind of a demo now, and show you actually a few tasks that run. So here I kind of have multiple terminals open that will be used for different things. Here I have a run server instance that I'm going to start up. Here I have, hard to see, but Celery EV is the monitoring tool. Actually, maybe I should know. This is here I have just a Jingle shell. And I think I accidentally closed the Can you see that okay? More or less. Actually, I just try that. So I'll activate here. So I'm doing Celery D. I'm passing capital VE in, and then logging info. And here you can see it says events are on. That's because I just specified the E. Celery beat is on. And then here it's got all sorts of debug information, or debug information. It looks like it detected all the tasks that are available. And start Celery Counter. Here, I'm gonna, looks like my Celery Can instance is gone too. Okay, so it says here it's starting Celery Can. It's going to take a snapshot of the current task every second and adjust that. All right, so I have a. By the way, I posted this stuff on like a sample project on GitHub. So if you want to try it out, I have some of the basic information here. Like a basic project you can kind of start up and play with. So here I'm just importing my tasks. I'm going to do just a simple task first. And it's in there. So it ran instantaneously, apparently, but it really ran in the background. And it's an asynchronous result, which find some information about. Task name, these are all the things I kind of showed you. Here's the unique task ID that it gave. Now if we look at Celery Cam, I'm sorry, not Celery Cam, Celery D, you'll see that task came in. Here's the task ID. It says it succeeded in 10th of a second. And if we look at Celery EV, we see, again, here's the task ID name, which is a nice little graphic tool for this. You can kind of scroll up to it. What's really neat is you can you get some more information about it by hitting I, and here's the result, the success, etc. Okay, what the other R's and R's. That's kind of neat. So I wanted to try the more complicated example of the rabbit here. To show you kind of how it spawns a bunch of stuff. So for I in range 0 to 1,000. Tasks I'm going to add asking the R's 1 and 2 or something more interesting. A little bit more interesting. Okay, so here it's spitting these out, scheduling these tasks, and my virtual instance is slowing down. Here on Celery D, you can see him receiving these tasks. Here, you can see all these tasks being processed, and there's 1,000 of them, so it's going to be doing that for a while. But it goes relatively fast. It's a simple operation. Some important notes, let's see. Oh, if you make a change to your tasks, you have to restart Celery D in order for it to take effect. Just like you have to restart, if you're running Nginx or something, you got to, if you're running Flup or Jingle, you got to start that process in order for it to take effect. So that's just something. Concurrency issues, I just made a note of that because they're easy to bump into when you're running tasks in the background, so just be careful. There's a few things that, now when I was running RabbitMQ, I just noticed that it's taken up, by default it takes up like, allocates I think 40% of your RAM, which is a lot of memory. So you can adjust that in your RabbitMQ config with this memory hide watermark, which I set to 10%. I mean, I've noticed that it feels like Celery takes up a lot of resources, so you know, you probably want to use something simpler if you just have a basic thing you want to queue up, but maybe there's ways to optimize that. Here's another little interesting setting you can play with, Celery prefetch multiplier, and basically that specifies how many tasks this like grabs at a time. If you recall, as this list was processing, it was like fetching various things. It was fetching like 4 at a time. If I set that to 128, like in that setting there, it would supposedly fetch 128 of those and start processing. And I was looking at the docs and it was saying, you know, you might want to adjust that depending on like if you have a lot of small tasks, like in this case, or you have some large long-running tasks. You can make some decisions based on what you want that to be. There's a I don't know if you've used Supervisor D or Supervisor. There's a nice little project for managing various daemons and stuff. There's a nice little Django wrapper for it called Jingle Supervisor, which kind of wraps a management command around it, and you can define your supervisor configuration in a nice little template syntax. So you don't have to hard code any. Like static paths in there and stuff. Like you can use the Django projector. I think that's in Python. Those are some variables that Django Supervisor gives you to access to in this configuration. And yeah, Supervisor just lets you manage these daemons, so you don't have to do it via the init process. And it you can start and kill them with a nice little either interactive interface or command line options. It's kind of cool. And then this is something Larissa was pointing out. There's a you can kind of integrate Django, Celery, and Sentry. And Sentry is like a error reporting tool for anyone who's not familiar with it. Basically, in Django, if you get an exception that would throw up an error page, this Sentry application will kind of take the place of an email when you're in a production environment, so you can view all your errors all in line and mark them as fixed or not, things like that. So I won't go through it here, but there's some instructions in a link on how to set that up. I haven't done this myself, even though I'm now seeing this. I plan on trying it because it looks pretty cool. You can integrate Celery, so your Celery exceptions will be caught by this by Sentry in there. Some resources. Here's a link to the GitHub profile, which has that demo application. And then a while back, I did a blog post on this that I kind of use as a basis for this. And a lot of this stuff is accessible in the Celery documentation and the Django-celery documentation. So they have some really good resources there, so be sure to check that out. So I guess that concludes the scripting portion. Does anyone have any questions?
You said you had to restart Celery D for code changes to take effect. Does Celery D have a graceful shutdown? You know, complete all processes, its tasks that started and then shut down.
See, there's kind of a you can hit Control C once and it will like try to like wrap things up nicely. And then if you hit Control C twice, it will like do a forced shutdown, a cold shutdown. I haven't had any bad consequences happening to that, but probably it's best to let it gracefully shut down. And I think I know RabbitMQ has some nice management commands with that control, RabbitMQ control, that you can stop its service nicely, but I'm not sure about Celery specifically there. One nice thing about RabbitMQ, for example, as a backend, as a broker, is that if it crashes, it will be able to restore status. It's got like a persistence layer that can kind of recover a little bit from that. Any other questions? Sure.
If you're running Celery, I mean, and you're running Celery Beat, then you pretty much don't have to use cron for most things. Have you tried that? Like, if I set something like 30 days out from now, I'll set the countdown out pretty far ahead. With the whole like stack of RabbitMQ Celery, I'm pretty much guaranteed that it would go off at that point. Because one of my questions was if RabbitMQ like was persistent between reboots, and I think you kind of answered that one. But
Yeah.
I don't know if you've tried that use case and had any issues with it, or.
I've tried that use case. It seems to work okay. Then again, I think some people say that Celery isn't the best for like a long-term scheduler like that. I mean, but I think it fits the job in that kind of stuff sometimes. As far as cron replacements, honestly, there's a lot of configuration and overhead to run when cron, sometimes kind of nice and handy.
And there's nothing in Celery that does the every day kind of thing, right? You'd have to queue up 365 things if you wanted something to fire every day for a year.
Yeah, you do that. Well, actually, there are I didn't cover this, but there are like scheduled tasks that you can run. So periodic tasks.
Okay.
And you can basically set the period instead of using the task decorator. You could use this a different decorator with options to it and schedule it periodically. Also, there's a different syntax for declaring tasks to give you a little bit more control. I recommend looking at the docs. Any other questions?
So I'm not sure if the supervisor slide you showed did this, but if you're using Celery in production, would you have to reboot? You have to run this command management Celery EB every time you pushed a new version of your code? Or is there a way to maybe automatically run this?
Well, the supervisor thing is kind of what manages that. You can just restart all of your supervisor apps or processes, and it will just restart that. I haven't done too much with supervisor. I've played around with it, but I haven't used it in a production setting, so I might progress it for stage.
It can be a bit difficult.
Yeah. Good to know.
But there are a lot of options. Have you had any trouble using debuggers on code that's running under Celery?
I haven't tried,
Okay.
but getting the information out is always kind of tricky sometimes. But what's nice is if you're doing it interactively, at least have the stack trace via the result. There's result dot, something like stack trace or something. That will give you that. There's actually one more thing I want to show, which I forgot, was the Django admin interface for it, which I think you maybe find interesting. It's basically this, except it uses Django to store that stuff. I'm gonna just kill Celery canned unserved. Okay. Oh yeah, well I guess I had it open, but so here it's a nice little display of this, and you, because it's a stored in a Django model, you can also get access to it programmatically. But it's got all that stuff you basically saw in the result. Kind of nice. And then also here you can set up periodic tasks through the admin interface. And you can set up like cron tabs, which is like simplified cron-like syntax. Any other questions? All right, great, thank you. Let me know if you have any more afterwards.